Hi everyone, Plus2 here, doing Scholarship Calculus 2024, question 3C, 2. This is a challenging question, I admit, but I didn't give up. So let's dig in. Show that u equals 2abc over b squared minus a squared and find a similar expression for b. Hence, prove that a squared plus b squared equals c squared. In the following formula will prove useful. So this is the sum of series, right? I found that this is better. If it is infinite, it goes to a over, so yeah, a is the initial, 1 minus r, when r is less than 1. So if r is greater than 1, you just swap r minus 1. It will do. Anyway, so to prove that, to find the u first, this is like say this is a t1. Well, yeah, T1 is better. T1, say T2, T3, so on, right? So then you have to add them up to find the U. So similar way, you find the V, right? And then we go sine, you see, this is 2 alpha, isn't it? Sine 2 alpha equals U over V. So once you find the U over V, then you use this. That's why question 1 is like this. Sine 2 alpha is 2ab over c squared, right? So from there, you can derive the Pythagorean theorem, which is c squared equals a squared plus b squared. So U, so we have to use this sine alpha equals a over c, isn't it? That's the same as cosine beta, isn't it? Cosine beta, right? And cosine alpha is b over c, which is the same as sine beta. All right. So cosine alpha equals 2a over t1, isn't it? Which is b over c. Hence, t1 should be 2ac over b, isn't it? So knowing that t1 is a 2ac over b, we have to find t2, and then we find that the common ratio, isn't it? So to do that, I set this one x and that one y, right? So using trig to find the x, turns out 2a squared over b, and y equals 2a cubed over b squared. Okay, so t2 equals it turns out t2 is, yeah, let's find it out. t2 equals t2 over, sorry, I can find this way easily. Y over t2 equals cosine alpha. Cosine alpha is b over c, right? So t2 equals y, which is 2a cubed over b squared over bc, b over c, I mean. So that means, what is it? 2a cubed c over b cubed, isn't it? So now we can find the r because we have a t1 and t2, right? So I'm going to use here. So that was the answer for question 1. So t1 is this, t2 is that. So t1 times r equals t2, isn't it? So hence r equals, isn't that a squared over b squared? So that applies to not only here, but that's similar triangles as well, right? So this is really important step. So R equals oops, A squared over B squared. So knowing that, you know, the sum of T1 to, forever. So U must be A, which is T1 over 1 minus, what did I say? A squared over B squared. Yes. R is A squared over B squared. A squared over B squared. So what is T1? T1 was 2A, say 2AC, yeah, 2AC over B. 2AC over B over, so if I simplify this, B squared minus A squared over B squared, which is 2AC over B times B squared over B squared minus A squared, isn't it? B and B gone. So that becomes 2ABC over B squared minus A squared. So we proved U equals that. Then V was hard because I made a mistake that, sorry, to find the V. I thought here, let's say this is a P1, P2, so on. I thought P1 is a C, and then I struggled with finding R. It's different from this R, isn't it? It's not. So this is not P1. So this is a special case. P1 starts from here, P2, P3, and so on. Okay, so that you have to add C on top of P1, P2, P3, so on. It is a V. So I'm saying V is a C plus the sum of P1 to, yeah, I can say Pn, right? So that's same way. We have to find the P1, isn't it? The first one. So to find the P1, that's simply cosine alpha. So x over P1 equals cosine alpha. Cosine alpha is B over C, right? And x is, so P1 equals x over B over C. What is x? X was 2a squared over B, and then times by reciprocal, is C over B. So which is 2a squared C over B squared. Okay, 2a squared C over B squared. 2a squared. So C plus 2a squared. My memory is not good. 2a squared C over B squared. 2a squared C over B squared. All right. Over. So do you remember this formula? A over 1 minus R, isn't it? And then 1 minus R is, what was it? R A squared over B squared. A squared over B squared. So equals C plus 2A squared C over B squared times by reciprocal, isn't it? I can, the common denominator is B squared. So B squared over B squared minus A squared, right? So equals C plus B squared and B squared is gone. And then we see 2A squared C over B squared minus A squared. And then we combine the C. So B squared minus A squared. I can just multiply by c, b squared minus a squared plus 2a squared c. So if I expand, I see b squared c minus a squared c plus 2a squared c is plus a squared c, right? Over b squared minus a squared. So do you see if I factorize by c, now I get b squared minus plus a squared. We are doing something here, eh? Hooray. Minus a squared. So you see b squared plus a squared. We are getting there. So that is b. So do you remember at the beginning I said our aim is u over v to find the sine 2 alpha and then combine with this equation. So u over v. So u, I'll write u over v. So this is a sine. I'm gonna write the thing. So sine 2 alpha equals u over v. And do you remember u was this 2abc? I'm gonna use my input. Yeah, here I'm excited. 2abc over b squared minus a squared, and then times by 1 over v, isn't it? So reciprocal of this, which is b squared minus a squared over c b squared plus a squared. Now b squared minus a squared is gone, which leaves 2abc over c. I'm going to write the a squared first. Squared plus b squared, right? Equals what? So earlier, question 1 says c squared is, here. C squared equals 2ab over sine 2 pi. So sine 2 pi means 2ab over c squared, right? So we use this. That is the same as 2ab over c squared. By the way, I have to cancel out c, right? So 2ab the same, hence c squared must be a squared plus b squared. That is Pythagorean theorem. Alright, awesome. I will see you next time. Bye.